We want to revisit one of our stories, the modern-day space race. We saw a big accomplishment this week with the Philae probe successfully landing on a comet. I'm joined live from the U.S. city of Phoenix by James Rice. He has spent more than 2 decades researching space, especially Mars. He's been a co-investigator of the Mars Exploration Rover Project. Thanks for joining us.
Hi, Eileen. Thank you.
Let's start with Philae. You know, it didn't exactly end up where researchers had planned. How similar is this to what you experienced with the Mars rover? And do you think Philae will need to be repositioned?
Yeah, you're correct. It didn't land exactly as advertised. It appears one of the legs is up in the air, not resting on the ground, so it's not very stable. And the gravity is very low up there. That's what's causing some of these issues. The gravity is about 1/100,000th what it is here on Earth, so it's very, very weak gravity. For landing on Mars, we had a different system because Mars has an atmosphere, and we had, a heat shield, parachutes, and airbags with our rovers. So there's a different type of landing, and obviously we knew a little bit more about the surface of Mars before we landed on it than Philae did on its landing. But I think that, they're collecting data. Most of the instruments are working right now. They're not in the ideal situation for getting solar power, which is the biggest concern now because the batteries are going to drain down and if they can't get enough sunlight. And they're only getting about an hour and a half of sunlight when they were hoping to get 7. So it's causing some problems right now.
Well, you've been involved in the process for selecting every Mars landing since 1995. How difficult was it for the Europeans trying to target a landing site on the comet? Would you say a little bit of information is better than nothing at all?
Yes, actually the Rosetta spacecraft, which carried the Philae lander out, got in orbit around the comet back in August 6. And Rosetta has cameras on there. It's been mapping potential landing sites. So they've been studying this for about 3 months where to land. So they had some information. You never know exactly until you do it. So it's a risky thing. It was quite an achievement that they were able to get it down there. And, it bounced a couple times when it landed yesterday. The first bounce, it went up and back in the air and stayed in the air for about 2 hours. And the comet is rotating under that. Then it came back down and did a more gentle bounce, but it bounced a second time. So we're not exactly sure where it landed, but we do know it's not in an ideal situation because it's being in shadow, probably near a cliff. And that's causing some of the concern with the battery power since they get recharged by the sunlight.
With all these different types of projects, the landing date is typically years away from the launch. It took 10 years for Rosetta to get to the comet. So with the missions of the future, are they always limited by the technology of today? You're kind of planning ahead and anticipating what could be a decade from now, would you say?
Well, that's right, and you're exactly hit on a good point. The technology that landed in this mission it's been in space traveling for 10 years, but it's actually older than that because it comes to a point where you have to freeze the design and get ready and fly it. So, this is not state-of-the-art 2014 computer technology or space technology being used. It's, been traveling 10 years, went over about 6.5 billion kilometers. And right now, it's a phrase that gets used a lot, but this is rocket science. It's very hard stuff, and it just takes a lot of work and is risk involved. But those of us who are involved in this wouldn't trade it for anything for the sheer excitement of being able to explore for the very first time different frontiers in the universe.
All right, James Rice, thanks so much for joining us from the U.S. city of Phoenix.